And welcome to the Daily Space Weather. We've got another solar uptick here. We've got more sunspots appearing in the northeast. Very high likelihood of major solar flares as a result of these sunspots setting in the southwest. Most of the activity in the southern hemisphere. And hey, lots of exciting stuff today. We've got 11 different clips to show you. So let's do it. This is just our intensity gram. Again, lots of sunspots, an uptick in the radio flux, and you can expect to see that continue. Here's our SDO colorized magnetogram. Most likely place to see solar flares is certainly down there in the southwestern limb. Pretty high likelihood of seeing some up here as well. They're all beta gamma class sunspot groups. Here's colorized magnetogram plus 171 angstroms. Again, lots of clips of the sun today, and a reminder, Volcanoes is continuing to erupt. The magma appears to be from the same batch of magma that the last eruption was. So this is just some more magma from the same magma reservoir, and it's expected to not even cause any damage to any infrastructure except maybe some hiking trails. So Volcanoes continuing to erupt with a new giant fissure vent opening. And here's some imagery of that. Some great drone imagery there of the Icelandic volcano. Hot, molten magma becoming lava as it appears on the surface. Anyway, let's move on to cite the rest of the volcanoes erupting around planet Earth. Karimsky producing a 24,000-foot ash plume as it explodes there on the Kamchatka Peninsula. That's an uptick at Karimsky, I believe. Shivaluch, 15,000-foot ash plume as Shivaluch explodes also on Kamchatka. Sakurajima, flight level 080. It's an 8,000-foot ash plume over Kyushu, Japan from Sakurajima. Suwanosejima, 7,000-foot ash plume, flight level 070. Mount Ibu down in Indonesia, flight level 070 from that. Nevado del Ruiz headed down to Colombia now. Nevado del Ruiz exploding, flight level 220, 22,000-foot ash plume. Ecuador features two exploding volcanoes, Sangay and Revenador, 21,000-foot ash plume from Sangay, 16,000-foot ash plume from Revenador, and continuous emissions from Sabancaya are a reminder to not pole vault the caldera. Do press like, do press subscribe, do leave a comment. Next seismic report. No major quakes over the past 24 hours. There's your 90-day bar graph from volcanodiscovery.com. We did see some 5 magnitude quakes. I think that was it. Nothing larger than a 5 magnitude. So there's a quake south of Kamchatka. There's a quake at Japan. Those are both 5 magnitude quakes. Vanuatu had a 5.0. Again, no major quakes over the past 24 hours. I think that's the largest that we saw was a 5.0. Small swarm of small quakes there in the Caribbean. That looks like it's around Haiti, perhaps. Somewhere in the eastern Caribbean. Chile had a 5.0. There we go. Largest quake of the past 24 was actually a 5.1, I think, at Papua New Guinea. That one coming in at 3:53 this morning, Universal Time. All right, let's get back to this. And that is the spot to watch, folks. Let's just pause for station identification. This is the Smash News Network least busted name in news. Whew. So here's our ionized helium view from the SDO. And those 3 sunspots are very likely to produce major flares. That was a 24-hour video, by the way. This is 24 hours as well. All of our custom clips today are approximately 24 hours of solar activity. Keep an eye on the northeast and the southwest. Major sunspot groups in both of those areas, but this is the most interesting of all and the most likely to produce large flares. Yes, sunspots more likely to produce large flares as they set on the limb. Perhaps solar flares are anisotropic, meaning they're not the same intensity when viewed from all perspectives. Radio flux now up to 116 solar flux units. There's the 1-year chart of the radio flux, and we're climbing back up, seeing another conflagration of major number of sunspots. So also NOAA forecasting some geomagnetic unrest late in the day tomorrow and early in the day on Tuesday, August 9th. So some geomagnetic unrest there as a result of coronal hole high-speed streams. We have recently had an uptick in the solar wind speed as well. We'll get to that momentarily. And you'll see an uptick here in the magnetohydrodynamic pressure. So this is the last 4 hours, Earth's magnetic moment from space. Again, we had a little uptick in the solar wind speed, which was pretty boring the past couple of days. And any little signal makes a difference. So it has generated some aurorae as well. We'll show you that first, Earth's magnetic moment from the ground, and quite a bit of ground magnetic perturbations here at the moment. Like the last video, this is the last 4 hours. Ground magnetic perturbations, it's all based on the space weather modeling framework. The scale here, nanotesla magnetic flux density. So we're actually going to show the 30-minute auroral forecast, since there have been some likely aurorae kicking up. And it's been a while since we showed this imagery. You'll see here at the end of these videos, there's our little increase in the aurorae. Some aurorae showing up perhaps in places like Minnesota there. And the KP index is at 3. Again, we are expecting some geomagnetic unrest KP4 conditions. At least NOAA is expecting them late in the day tomorrow and early in the day on Tuesday. So we did see a big increase in the magnetic field as well. Magnetic field making it all the way up to about 14 nanotesla there. And this strong negative BZ component, this red line here being strongly in the negative, that induces more currents, and that's what's kicked up those aurorae, that geomagnetic, ground magnetic perturbations. It's starting to subside here. We're losing some strength in the field, and the BZ is moving toward the 0 line, at least at the moment. Current conditions are about 12.8 protons per cubic centimeter for the solar wind density, solar wind speed about 420 kilometers per second. Next, looking at magnetic data real quick before we show lots more imagery of the closest star. Here are GOES magnetometers. You can see some fluctuations happening in that. That's a result of some higher speed plasma showing up. And here's our heliospheric current sheet imagery, the top view ecliptic plane field plot, showing the polarity of the plasma. Earth remains in a North Pole current sheet, shown there in green. Here's our line of sight field plot. And we do have coronal holes that are North Pole oriented facing the Earth. Here's our coronal hole line of sight plot. And some new South Pole coronal holes here rotating in on the east. So here's some SDO imagery of that. Well-defined coronal hole here. Again, we are expecting some high-speed solar wind and geomagnetic unrest. Transequatorial coronal holes are the most geo-effective type, folks, because, well, Earth is always fairly close to the solar equator. And let's continue on to look at sunspots. There are lots. 3068, 3072, and 3073 are the most likely places to see major flares. Also, we may see some from these groups up here. And there are now 3 groups up there, I believe. Those will be known as 3075, 3076, and 3077. So lots of sunspots. This number is going to go up as the day increases. Flare probability, in my opinion, much higher. We've seen a very underperforming X-ray profile here over the past couple of days. So here's our sunspot imagery. There's our SDO continuum. Here's the southern hemisphere. And these groups in the southeast, they're not super exciting. This is an alpha class sunspot, it looks like at the moment. This is a beta gamma class sunspot. That one's more likely to produce flares than this one. Well, there might be some umbre there. I'm not sure. That might be beta class. It's close. These groups up here are much more interesting. I think there are 3 groups up there now. Yep, so you can see a third one forming right at the end of the video, right up here. So that'll be 3 sunspot groups, 3075, 3076, and 3077 forming. You can see that, especially this one up here at such a high latitude, showing us that solar cycle 25 is nowhere near solar maximum. Again, the most exciting spot on the closest star at the moment from Earth's perspective is this group in the southwest. Don't be surprised to see major flares from that group, M or possibly X-class flares. You can see how underperforming the X-ray flux has been here over the past 3 days. Only 1 C-class intensification over the past 3 days. If we do see major flares, a good wavelength to view is 131 angstroms, also 94. The heck? There we go. And as always, showing you the most detailed imagery of the closest star that you'll find anywhere on the internet. The most comprehensive space weather is indeed here at the Smash News Network, least busted name in news. Proton flux remains flatlined. If we see a major flare, we may see a spike in the proton flux. We may see some polar radio blackouts going on if we do see any relativistic particles showing up. And we've brought up a star chart here as we do daily. We prefer people to be oriented. The sun has just risen in the past about hour here in Lehigh Valley. We're coming at you a little later today than normal. If you're up before dawn, you may see Venus, Mars, Jupiter, and even Saturn in your morning sky. Here's your solar system forecast. This is where things are now. And by the way, this is theplanetstoday.com. And here's the 1 week forecast for the solar system. We're approaching another full moon. We've got a gibbous waxing at the moment. And there's where things will be at a week on August 14th. We did have a sun diving comet that we're going to show here in a moment. I think it's broken up because we don't see it in this coronagraph imagery. This is yesterday from the Soho-Lasco C2. We do have some coronal mass ejections there. Are they earthly directed? Well, we'll let you know in a minute. Here's today's imagery. And you can actually see that comet. It looks like it's quite broken up by the time it reaches. You'll see this little streak right here. That is indeed that sun diving comet. And we'll show you some better imagery of that here in a moment. So here's the view from Stereo A at Lagrange 5 and Soho-Lasco C3 at Lagrange 1. And you'll see that comet over here on the right side imagery. You can actually see it in Stereo A as well. Right there you can see that comet. Here it is on the Soho-Lasco C3. Changes its trajectory a little bit and grows a tail there. Now, regarding the coronal mass ejections, they're on the opposite side of the sun. They're nowhere near the Earth. For your new viewers, from Stereo A's perspective, Earth would be off on this line approximately. And we don't see any coronal mass ejection material on that line. It's just a stellar light show Nothing earthly directed. So some great CMEs there and cometary material all happening at once. It looks like it breaks up around that moment. A couple hours of missing data there were not helpful, but it looks like it is breaking up indeed. Next, we're looking at hydrogen alpha. This is the El Teide ground-based solar observatory, and lots of filaments here. So not only are flares becoming very likely, coronal mass ejections becoming very likely as well. On the earthly side of the sun, you can see all these dark absorption features there. Those are filaments. Some prominence is up here in the northeast. Solar flares, very likely, and CMEs, very likely. Here's our GOES 16 SUVI imagery. This is approximately the last 2.5 hours. And here's the 24-hour imagery from SDO in the same wavelength, ionized helium. Next, let's blast through our bonus features segment. Starting out with the satellite's community dashboard. Some charging hazards here moving into the Central Pacific Ocean at the moment. They are minor surface charging hazards caused by low energy electrons. Here's the electron flux over the past 3 days. Pretty low. And expect it to remain low with that little uptick in the solar wind speed. Also, when the coronal hole high-speed stream shows up, we can expect this to be down here until that coronal hole high-speed stream subsides. It won't be a really long-lasting coronal hole high-speed stream, maybe about 12 to 18 hours. Here's the 1-year chart of the relativistic electrons from solon.info. Again, pretty low levels here. And let's take a look at the F-ionosphere layer next. So here's the F-ionosphere layer. Again, we're coming at you a little later than normal today. It was our Sunday sleep-in. So there's the vibrational frequency in megahertz. Here's the anomalygram. And some differences here in the anomalygram showing up. A lot more high frequency anomalies showing up today, and a lot bigger swings. So some different frequencies happening up there in the ionosphere. High frequency shown in blue, low frequency shown in red. Here's the latest image. That's 11 o'clock Universal Time ionogram. There's the 11 o'clock Universal Time anomalygram. Next, the total electron content forecast. It'll show you the most likely places for GPS errors, for example. It's showing you the total electron count, the free electrons in between your GPS satellite and your GPS handset. We are seeing some major anomalies here, actually, in the southern Indian Ocean, for example. And your GPS satellite, it must communicate through 2 plasmaspheres, sometimes the Van Allen belt, the inner one at least. It's located about 12,500 miles of altitude, and if it has to transmit a signal through a lot of free electrons, you'll have a refracted signal. Most people around the equator know their GPS won't work well at noontime. Anyway, that's the total electron content forecast. So this is your GPS satellite. It's located right on the inner portion of the outer Van Allen belt, and this distance is about 12.5 thousand miles from your GPS satellite to your handset. Next, we'll show the latest intensitygram and latest colorized magnetogram as we do on the regs. And those groups right there, again, very likely to produce major flares. Next most likely to produce major flares would be these groups up here. They are quite magnetically complex, especially the middle one. This one right here. And as they get farther from the limb, they become less likely to produce major flares. As these groups down here get closer to the limb, they become more likely to produce major flares. These other southern groups, much less magnetically complex. And we'll bring up one more series of images here from the SDO before we close out our space portion and move into our meteorology portion. This is Iron Star. The data is from yesterday and today. It's 3 species of ionized iron, 335, 193, and 94 angstroms. Keep in mind this shows those wavelengths in different colors. It's showing 94 in red instead of green, 193 in blue instead of pink, and 335 in green instead of blue. But great composite imagery there from SDO. So let's move into our meteorology portion. First, some shoutouts. Station identification, once again. This is the Smash News Network, least busted name in news. Don't forget to follow us on Twitch. Thanks to our followers over on Twitch, twitch.tv/smashomash. Don't forget to press like and subscribe if you enjoy the content on YouTube. Press share, etc. Check out our playlists. There are videos on the channel that have nothing to do with space weather, so check those out. Interviews with other channels, such as Shout Out to Eugene the Philosopher. I don't know why Tyler Fisher's video is appearing there on our playlist, but hey, shout out to Tyler Fisher. He is hilarious. You can even find driving, riding, and pro tips. Thanks again to our YouTube subscribers. If you want to support the channel, as we make just this side of nothing to put the videos on YouTube, consider becoming a member of the Smash Team. Go join at the silver or gold level at smashomash.com/smashteam. We replaced Patreon with a superior website, our own, and that post is actually public. Major solar uptick, the GDAX daily reports are only for gold and silver level Smash Team members. Smashomash.com/smashteam. We replaced Patreon with a superior site. Also, if you want to support us by picking up some merch, pick up some merch. This is in order of best-selling. Let's not leave that on the screen too long. We don't control what the best-selling merch is. However, I wear it myself, and I'd like to implore you to Mensa, make Earth not suck again. And also, you know, our bestseller, it's our bestseller. Make Earth not suck again. If you've noticed, there's a bit of a consensus going on that Earth's been sucking lately. Would you tend to agree? Well, it's up to you to make it not suck. So please do your part in making Earth not suck again. Start a conversation. Perhaps it's a little bit too provocative for certain people. I don't know. It's not designed to make you mad. And if you think the channel is politically oriented, well, think again. I've never been associated with any political parties, and I probably never will, because I am way too nuanced on all of the issues to conform to any nonsensical political parties. And, of course, I'm wearing the baseball cap. It's a very high-quality baseball cap, by the way, as well as the print quality. Make Earth not suck again. It's up to you. Links below the video, as well as on the homepage at smashomash.com. And if you'd like to improve your health, consider joining SureMed, otherwise known as the American Better Health Organization. You can find a link below the video as well as on the homepage at smashomash.com to that as well. And believe me, folks, it is worth it. It's worth the $20 a month just for the teledoc service. Because, hey, going to a physical doctor is so 2019. So check out those links as well. Again, you can find them on the homepage right there at the link to my SureMed page on smashomash.com on the homepage. And welcome everybody to the Neo Renaissance. the official homepage of the Smash News Network, least busted name in news. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground where we survive, as produces a fortune. If you have a problem, like crappy, nonsensical content on the internet, like on YouTube, if you have a problem, if no one else can help, and if you can find the videos, maybe you can hire the Smash Team. You certainly can hire the Smash Team. Just head to smashomash.com/Smash Team. Click the link below the video or on our homepage. And once again, welcome to the Neo-Renaissance. Citing facts. Next thing we're looking at are currents. We're looking at currents, not waves, currents, and sea surface temperature anomalies. Check it out, some hot water here in the northern Pacific, 9.6 degrees Fahrenheit below normal, and some cold water here in the central Pacific, 5.5 degrees below normal down there. We're reporting on all of it. What's going on around Antarctica? Fairly average. What's going on around the North Pole? Some hot water over here, north of Asia, and some cold water north of Alaska. We're also going to show the Gulf Stream. So here is the Gulf Stream. You can see it flowing up here and making its way to Ireland. A bunch of hot water here in the North Atlantic at the moment. Lake Superior remains very, very cold. Very cold. 10.8 degrees Fahrenheit below normal there at Lake Superior. And this hot water in the North Atlantic, 10.3 degrees Fahrenheit above normal there. Anyway, once again, that's sea surface temperature anomalies and ocean currents. There's the Indian Ocean. And let's talk about heat latency. Did you know that the Earth's heat latency lies in the oceans, not in the atmosphere? Less than 1% of Earth's heat latency lies in the atmosphere. Water takes a lot of energy to heat up and cool down, unlike air, which you'll notice heats up and cools down very rapidly. Oceans, not so much. So you can measure the atmosphere all day and not understand the Earth's surface heat latency. You must know the temperatures in the deep oceans to truly expect to know what the planet's surface temperature is. Let's leave that there and look at the jet streams of the eastern world. Strong anticyclone here over East Central Asia, rotating clockwise as they do in the northern hemisphere. Here are the surface winds of the eastern world. Here are the surface winds of the Americas. Here are the jet streams of the Americas. We've got some backward jet stream here over New England, blowing down into the central U.S., and some southwest-oriented jet streams here along the east coast there. Here are the jet streams of the central world, Africa, Europe, and the Middle East. And here are the surface winds of the central world. And let's continue on. By the way, make sure you follow us on Twitter, twitter.com/smashamash. We started a hilarious conversation yesterday with some chemtrail types. Twitter.com/smashamash. Also talking about some low-hanging fruit, flat earth discussions. Yes. Twitter.com/smashamash. Don't be a baby. Go set up an account over there. You can survive the censorship. And here's our weather.gov map. If your county's lit, click your county at weather.gov. Lots of flooding here forecasted once again. Eastern Kentucky getting no respite. West Virginia, most of the state there in a flood watch. And large portions of southern Wisconsin. southern Minnesota, northeastern Iowa, and northern Illinois with flood watches. Once again, if your county's lit, click your county on weather.gov, and let's continue on here. Here's your total accumulated precipitation forecast based on the GFS model for the next 72 hours. And once again, let's pause for station identification. Thanks for tuning in to the Smash News Network, least busted name in news. Again, that's your GFS total accumulated precipitation forecast for the next 72 hours for the lower 48. Here is your pressure and precipitation forecast. It's also based on the GFS model, and it's over the next 72 hours. We show 72-hour forecasts on the channel because we don't sensationalize the weather. We show you accurate forecasts and cite facts, as opposed to nonsense. Next, looking at pressures. We've got some very low pressures here in the Southern Ocean. A series of low pressure systems here surrounding Antarctica. Check this one out. 942 millibars. 942 hectopascals, actually, which is essentially the same unit. And here's the pressure map for the Atlantic, the Pacific, and for North America. That's from windy.com, by the way. There's a great mobile app you can download for free. Windy.com. Lots of weather data for all you weather weenies. Here's our NASA GOES lightning mapper. Quite a bit of lightning continues over the U.S. And let's go to a real-time lightning map briefly. We do have some terrestrial strikes, it looks like, here. Chicago, you may be in the crosshairs. Looks like there's some thunder rolling in east of Cedar Rapids. Dubuque, also expecting some thunder. Check out lightningmaps.org next time you hear thunder. You could convince the natives that you're Thor or something. All right, we're in our final section of the video here. This is the U.S. Doppler radar map. We'll be focusing on the lower 48. And I think we've got some missing data here. Give me a minute to bring that back. Here's a shortwave radiation map showing clouds and fog. It's 3.9 nanometer infrared radiation from a satellite. Here's the water vapor satellite. You can see actually a clockwise rotation there. A lot of moisture there over the western Great Lakes region. Also, you can see the jet stream influence here blowing some weather systems down to the southwest. Not the normal mode for jet stream behavior, but that's where it is. Got quite a lot of moisture here moving into the east coast from the Atlantic Ocean. So here's your recap. U.S. Doppler radar showing vertical motion of water droplets in the air column here from our ground-based Doppler radar system. Let's see if we can animate that. And by the way, you can view it yourself at radar.weather.gov. Anyway, that's the current map. There we go. Now we've animated it, and it looks like Chicago is going to get some serious weather here. So those are some pretty severe thunderstorms there. Don't be surprised to see some wind and maybe even some hail. Hopefully no tornadoes. But there is some red showing up there on the map. Here is your shortwave radiation showing clouds and fog. And there is water vapor. And that moisture getting constrained a little bit there by that dry mass of air to its southeast. Hopefully that helped. Thanks for tuning in to the Daily Space Weather and more. We'll talk to you soon from the Smash News Network. Least busted name of news. May that solar wind be at your back.